Hi folks, Mr. Thessalonian back here again. I want to take you through how to take a standard bicycle like what you're looking at here, a pneumatic pump, and a small rim like this one here with a small sprocket on the other side. So we can use that little piece right here for driving a chain. It'll also be our flywheel piece. We're going to take all of this and some extra little parts. We're going to convert this into an air-powered bike. So I've kind of got this dry set together just as a quick test to make sure all my linkage is the right size, all the lengths are correct for the throws and the stroke here. We've got our mount here holding the old bicycle hub across the center of the frame. We've got our gear sitting there with a chain going down to our lower gear drive that's driven by the pedals. So it's our drive system's all preliminary mounted. We're going to build some nice brackets here that'll actually screw right onto where your water bottle once went. So what I'm going to do here is just really quickly, without a flywheel, I'm going to have to adjust this after each stroke just a little past top dead center to allow the next stroke. But I'm going to give you a quick shot with some compressed air of how this is going to rotate. So let me go ahead and give it a blast right here. You can see how nice that pulled that right in. And if I just rotate just a little past center there and give it a blast in the other side, goes right over, little past center, and that's what your flywheel is going to achieve. Pulls it right back across once again, and you can see here I've got a separate hose to go into the other side. There we go. So, as you can see here with the flywheel incorporation into this, or something to carry the inertia of the stroke around just maybe a 1/4 inch past where it stops naturally on its push, we're going to be able to have a nice running piston engine here. So what I'm going to do now is go ahead and start building some permanent mounts for this to hold our piston to the bike frame, and some permanent mounts to hold our bicycle hub here so that it's ready to go. It'll be one solid unit. I showed you the preliminary mount. I was kind of figuring out all the measurements and the lengths and everything here. Now I've got it mounted to a hard piece of iron. It's an angle iron piece back here that you can see it to. That's bolted down to where the old cup holder or the bottle holder screw holes are in the frame of the bike there. We've got the piston mounted hard right to that angle iron. We've got our flywheel set up on the other side there, you can see. We've got our camshaft or a crank arm here. Everything's mounted up. And what I'm going to do now is just put some air from our air hose into each one of these pistons. It's kind of allowing you to see that the flywheel over there is rotating the system all the way through now. So we're basically ready to start setting up for our valve construction, which is probably going to be one of the more difficult parts of this entire project. I've got to now make a valve that's going to actuate when the piston gets past top dead downstroke and comes around just slightly, open up that piston, blow it up. It's also going to have to do it when it gets to the top of the stroke. It's going to have to open up that valve and blow it back down. So there you go, folks. Just a real quick demonstration there for you. Just how it's getting itself past that top dead center, allowing for the other stroke to take place without binding the shaft here or the linkage between everything. I'm going to go ahead now, take the camera off the stand, show you what it looks like, the mounting and how I've mounted it to the bike. Let me walk you up to this and just kind of show you how I've built this mount, the linkage systems. You can see here my piece of steel still needs some bushings between it or some washers between there on the jaws. It's going to need a better bolt here. I just set this up really simply just to get my distances and the rotation, make sure the flywheel is going to rotate past without hitting to the end of my stroke in either direction. All of that I like now. So we're going to make some permanent parts on the lathe in the mill to replace this little bolt here. We're going to machine out some washers right here. Now you can see this piece of angle iron. If I get the camera perspective right there, you can see it's a piece of angle iron. And on the inside you can see these two screws that are holding a rather nice piece of steel strap over the old bicycle hub, and that's got a lot of tension holding it in place, and it allows me to move it in and out just slightly to allow for timing and the linkage to be correct on the chain here. We've got the flywheel mounted. Let me go over to the other side here. You see the flywheel is just mounted off the bolt end that came out from the original hub that was going through the wheel there. As you can see here, that's the original bolt going all the way through that was on the hub. I've just put another washer and nut on this side of it. Alright folks, you can hear this hydraulic press running in the background for this big shear that we've got going here. And I've got a line you can see marked on the piece of steel. This is going to be our valve system. This will actually be the slide rod that'll contain the holes for the valve that I just showed you. That was the preliminary design. This is going to be the piece for the actual valve that I'm putting together. So I'm going to go ahead and throw this on the shear real quick. It's going to be a little noisy, folks. Give me just a second. Let's go ahead and open that shear up. Now I've got this all lined up in there. We're going to go ahead and fire up this hydraulic shear and make us a nice cut for our valve. Here we go. That should be it. We're gonna pull that out and take a look at our cut. We got that cut, and we use this little tool here to pull out our finger. So there we go. This is gonna be our little rod that we're gonna use for our slide rod for the valving. So this will have a single hole on either side aligned with the 2 valve inputs to that piston engine that we're working on for the bicycle air ram conversion. So let me go ahead now and chop out the rest of these pieces. We'll go to drilling holes and I'll show you what we come up with. Folks, I want to show you the valve that I've come up with. You'll notice here we have the 2 outputs to the piston here. And what I've done is created this simple valve. And I haven't got it all hooked up, but this is going to be our drive rod right here to actually actuate the valve. It's going to move just like that. And if you watch inside of there, if I bring that up closer to the camera, you'll notice there's a hole lined up on each spot right now. You can see through on both spots. Now when that rotates back just a little bit, it lines up the 2 opposite holes. Hopefully you can see through there and see what I'm showing you here. So that will be, for one of our pistons, that'll be air going in, pushing the piston forward. And at this side, it'll be exhausting the gas behind the piston. So once that gets all the way up, it's going to push this forward. That'll put air behind the piston here, pushing the piston back down, exhausting the gas behind the piston here. So that gives us both an input for our air pressure and an output for our exhaust pressure, and that should work just fine. Real quick, I just want to show you exactly how I made this. This is made out of a bunch of flat stock steel, just like this piece right here. You can see the holes in there. They're all the same thickness. So what I've ended up with here is being able to have a place where this rod can travel right between it all with a nice tight fit, because the rod here is the same thickness as the rest of the metal, leaving almost 0 gap. So a really nice tolerance between it. With a little oil, that thing's going to move really well. If I pull that out of there, you can see here the channel going all the way through there. That's our slide channel for the valve. And all I've got to do now, folks, I've got to be able to weld some boxes on the back of this or mount them all the way through. I haven't figured out how to do that yet. They're actually going to hold these air chuck fittings right here into that system. So these will be fit in just like that, 2 of them out of a box in the back, and that way I can actually hook this right up to a bunch of air chuck fittings. There are 2 air chuck fittings sitting out of that. We can hook it right up to those fittings, and if we ever want to take it off, we can just undo the 2 fittings and pop the valve right off the system. So I've still got to design that, put that together, and show you exactly what's going on there. But as you can see here, it's just a sandwich layer of all those metals right through there. And that created a nice channel, exactly the same thickness as the metal on either side here, giving it the gap. So that way you got a really nice tolerance to provide for a good valve. Here we are at the Bridgeport. We're going to go ahead and mill in some channels for our valve. You can see here I've got 2 preset holes ready to go inside of our rear block. That was a piece of aluminum, looked just like this. We're actually going to use this for the upper side of that. These 2 will sandwich together just like that. And we'll have a air chuck fitting off of one side and the air out off the other side. Alright, so we're finishing this valve setup. This is the rest of it here. We're working on the top blocks. Those 2 will go over this face right here. And on the back face you can see this aluminum skirt. I've got another one there. And what we're going to do here is drill and tap this for an air chuck fitting so it can thread right into those holes on that pneumatic ram. And that'll hold it right on there. We'll actually thread everything together with the aluminum, and then you'll screw all this onto the aluminum plate once it's on there. This should work pretty good. Let me show you that aluminum piece from the other side here. Alright, so you can see I've got some pre-drilled marker holes. I've got my 4 screw holes there to hold it onto the face. And what I'm going to do now is actually use that for my centering, drill a hole right through the center between those 2 marks, right out the back here, and then I can drill in for the fitting size that I'm going to need for threads to hook that right to that pneumatic ram. So let me go ahead now and mill out this channel for our first head block here. So this will go on the face aiming out from the engine, these blocks, and like I said, I'll put a couple channels in them, and we should be able to mount an air chuck and still have an air out that might in the end go to another air ram, just smaller in diameter with the same length stroke. Alright folks, so you can see this hole straight in front of you in the piece of aluminum. That hole there does not go all the way through, and what I'm doing right now is using the mill to slowly pull a hole right down the edge there, right in line with that hole, and that'll be our gas out on this valve. So let me go ahead and finish this and I'll show you what it looks like. So let me go ahead and finish this. You can see here we've got a hole going all the way through the block, and we've got one that only goes partially the way through and then comes out right there. So that's going to be our blow by. And this will be when the piston's on its stroke back, the air behind the piston will go through this and out that. And right now what we're going to do is on the top of this block, I'm going to go ahead and start milling a channel all the way across this. I'm machining in a little pocket right there. You can see the recess. I'm going to go ahead and give it a little more depth. and this will give an air pocket next to our air in. And that's probably going to do it just fine right there. So let me take the camera off and show you that. You can see this little pocket I've created in that piece of aluminum right beside the hole that's coming through from the other side. Well, I just showed you milling the hole over here in this face. That's our air out. This is our air in. So now I got to get this other block right here, and I've got to mill the same basic little port I just put right here with a threaded tap in there so we can put an air chuck, and we should have a completed valve system, just some holes drilled through it to hold it on there with some screws. Let me go ahead and finish this. So what you see here is just a mock together of that valve I just built. I have some zip ties holding it together for now instead of screws, but that's holding it right in place, and you can see just how thick this whole valve system is going to be. One piece I'm missing right now is I don't have a double threaded collar here. I've got threads on one side to go into the aluminum block, but I also need the same size threads going the opposite way so it can thread into the hole here. Now this side that you see done will sit right up to this like this. Right, so I pulled the zip ties out of the valve, and I want to take it apart and show you what it looks like on the inside. So you can see this piece is pretty simple, just has an inlet there, single hole going down, kind of offset. I milled in a little recessed spot there so the airflow can go by, and I've offset it just slightly from the main hole. That way I had plenty of meat here so I could drill through. And this valve, for its out, like I showed you earlier, there's the output right there. That would be the hole that allows the air into the output, so when the piston goes down it can push out the air. This is the hole that actually allows the air into the piston head right there, and that lines right up with this piece right here, just like that. And that gives us a nice double blow-by system that we needed, and those two holes obviously right there line up with those two holes that you see in the center there. So underneath this, just a pretty simple piece. I don't have the threads all the way done in here. You can see it's just got two holes, and then you got the 4 outer screw holes. And I've milled in a small recession into that also, so that you have your 2 holes on the back side, but you have a large hole here on the top. And that allows me to thread in our piece all the way down into that, so we can thread that into the piston engine. I've already showed you this piece here. Once again, I just got to finish now the opposite side. The same system I just showed you here out of a bunch of chunks of aluminum, and we'll be done with our valve. So right now I have those aluminum blocks holding onto our steel slide plate. The zip ties are just holding these double aluminum blocks that have our output side and our input side to the valving system. We have our valve rod here that's going to open and shut the valves. That's going to slide between like I showed you earlier. Now I just got to build some linkage off of all this. I would have liked this a little closer to the engine, but this is pretty good for what I was able to achieve with the parts and pieces that I had laying around here. We're able to mill out some of this like I showed you. Now I've just got to mill some kind of a linkage rod there, and I don't know whether I'm going to time it off the actual stroke of the wheel coming around or off the rod itself. So I'm going to get to that part here in just a minute, and I'll show you what I've come up with when I get there. I've got the valve set up all dry mounted onto the piston right now. I've got my linkage set up so it'll actually move the valve back and forth as the stroke of the piston happens. And I've got some air ready to go. So we're going to put some air into this. Now the blast on the back stroke is a little heavy, and it likes to slide this a little past where the valve opening is, so I'm going to need a stop guide at the back side of this in the end, which I'll show you when I get that done. But for now, let's put some air in this. We're going to blast it back. There you go. You watch it go all the way back. I put air in this side. It comes all the way forward. And there you go. In this angle, you can see at the tip of my finger, you can see some of the brass behind the valve hole on both sides here. So this hole and the far other side hole are right now open. Back here you can see our valve workings, and this is our valve rod. These are the little slaps that actually push the valve rod back and forth to move the position of our valve openings here at the holes. Here's what you're looking at. The center piece of shiny steel here is just a guide for our valve rod. It keeps tension from this side pushing the valve rod that way, while our 2 slap pieces here are pushing from the other direction, and that's keeping a nice even pressure on our valve guide rod there. I've got a horseshoe clamp for now that's on that valve guide rod to give me the timing for this slapper here that moves our valve forward. And also back here I've just got a nut with some washers, and I'm going to flip the thing around in the light so you can see what the other side looks like here in just a moment. We have some washers. That's the exact standoff distance for our back slapper to impact into. You can see these slappers are just hanging from this upper bar with a single screw in each one of them, right at the perfect pivot point so that when the lobe comes around it can slap them out, changing the valve position, go around without brazing into them the whole time, so there's not a lot of friction. It's just enough to slap them. and then it comes back around and once again hits this one. And without them being directly connected, these slappers, I don't bend my valve rod, so it's a nice clean push instead of some kind of linked timing with a rotator that actually starts binding up on your valve rods. So this is so far the best thing I've come up with for this style valve off of this air ram engine. Here we are looking from the other direction at the valve timing, our offset cam lobes, and all the rest of the system that I've put together. You can see here one of the pieces holding our cam rod on. I'm not sure what that went to, but it had the perfect size threading on there to put the old bicycle hub into. And I've had to mill out a face. You can probably see from this angle here, there's a flat milled face on there. I put that on the mill to give me a nice true center there. If I rotate this from this side, you'll be able to watch those valves slap back and forth. And it's such a minute amount of slap that it's perfect. And you'll notice how nice those work. And that's from an offset lobe that I've attached directly off the other side here of where our crank comes off. So there you go, folks. That was a really simple way. Now I still have to cut this all down. It's got markings on there to do that. I'm going to clean up all the pieces and the guides. I'm still going to mount the back end of this valve guide upper channel to the angle iron here to keep it nice and rigid back here while the valve's being operated from it. That'll give us pretty good rigidity all the way through the system. It should keep it nice and stable for us. Alright folks, so we've got our pneumatic air ram engine ready to go. I've got all the air lines ready. I've mounted my aluminum valve blocks and everything's on there. The one thing I noticed just a moment ago in my first test run was I need some valve stop guides, something that's going to stop the valve arm from traveling too far one way or another. Right now I'm only having an issue with the valve coming back too far because the slap from the slapper is pushing it back just a little too far. So I got to hold my finger just off from it and let this bump into my finger as a stop. And that keeps it running just fine. So what we're going to do now is hook this up to some air and give it a first test run. I got the compressor turned on here, and as the compressor starts to build pressure, the engine's going to start running fast, as long as I can keep that finger right at the exact right spot. There's some different shot angles, folks. Because again, I'm having to hold that finger right in the exact right bump stop there. And I can get the finger a little bit in a better spot. It starts running a little faster. From that angle there, you should be able to see how well that valve slap design is actually working for this. And it seems to be working and holding steady. So all our valving, all our rod design, everything seems to be holding pretty well. I'm pretty happy with this. We're going to go ahead and let the air compressor build up to a much higher PSI. Once I get these valve stops put on here, this thing won't need my finger sitting there, just acting as a valve stop. Now I can switch it over to a screwdriver. There you go, folks. So I want to show you what I've done here to stop the over travel that I was demonstrating in the last shot, where I had to hold my finger there behind the end of the valve rod. So right here at the tip of my finger, you see that little set of washers and little screw going through there. That's ready to go. We've got our bump stop ready, and that was very, very simple. I just had to get the right size washers. It stops it right at the perfect spot in the valve timing to create a higher RPM out of this motor. I'm only going to run it at low air pressure right now, but we're going to go ahead and hook up the air and take it for a run. I'm going to hook up the air line. So you can see there by touching the end there, I can shut it off. So there you go, folks. There's our air engine running at a low pressure. I don't have to hold my finger there anymore. Runs nice and steady. Let me change the camera angle for you. I want to give you a quick shot here from this other angle. You can see the slappers there in action. You can see the lobe. Let me zoom in a little bit for you. You can hear how nice and steady the timing is. It's an even stroke every time. You can hear how nice and steady that thing is. It's working really good. Apply some resistance to that flywheel. It's slowing it down a little at this RPM, but I can put quite a bit of pressure on that. So we can increase the PSI now and actually apply a lot more resistance to that flywheel. These pneumatic rams are capable of generating an incredible amount of force. So you can use this to run a generator. You could use this to power the bike like what we're going to do with it. We're going to go ahead and hook that sprocket like I said up to this. But at least at first, here's a working demonstration of an air-powered engine made from a pneumatic ram.